Good afternoon, viewers. We want to continue with our paper with number 17. And number 17 reads, it is given that vector p is equals 0 minus 3 and vector q is equals x1. Find item A, p minus q in terms of x in its simplest form. Then B, the possible values of x given that the modulus of p minus q is equals to 5. Now let's answer question 1, where we have our p equals to 0 minus 3, q equals to x1. So for item A, p minus q, this is the same as we are now taking the coordinates of p, 0 minus 3, 0 minus 3, and for q it's x1. Then we subtract 0 minus x, we get minus x. Minus 3 minus 1, we get minus 4. So this is p minus q for 1 mark. In question B, given that the modulus of p minus q is equals to 5. Now we are using the value of p minus q on item A. Then we are now going to find the magnitude of minus x minus 4. And so the magnitude of minus x minus 4, now we are now saying the magnitude of p minus q is equals to the square root of minus x in bracket squared plus minus 4 in bracket squared. This is how we calculate the magnitude of a vector. This is equals to minus x squared, we get x squared, plus minus 4 squared, we get 16. This is equals to the magnitude of what p minus q, which is 5. So we're now saying our 5 is equals to the square root of that. Now, to remove the square root, we simply square both sides. So squaring both sides, 5 squared, we get 25. P equals to x squared plus 16. Like terms together, this is 25 minus 16 is equals to x squared. 25 minus 16, that's 9, is equals to x squared. Therefore, our x is equals to plus or minus the square root of 9 to remove this square. So our x is equals to plus or minus 3. So plus or minus 3 are the possible values of x for 3 marks. So this is our final answer. Now number 18. Number 18, it reads, test the special name given to a regular polygon with 4 sides. A regular polygon with 4 sides. For regular, we are saying all the sides are equal. So the special name is a square. The special name is a square for 1 mark. That's the special name is the square for 1 mark. Then B, the angles of the hexagon. The angles of the hexagon are 115, 89, x degrees, x degrees, x degrees, and x degrees. Find the value of x. First thing, we need to calculate sum of angles of a hexagon. A hexagon has 6 sides. Now, sum of angles, we use this formula, n minus 2 times 180 degrees. So for n is the number of sides, so it's 6 minus 2 times 180 degrees. 6 minus 2, this is 4. 4 times 180, we get 720 degrees. So the sum of angles of a hexagon is 720 degrees. Now we add all those angles we are given, we equate them to 720 degrees to find the value of x. So we now say 115 degrees plus 89 degrees plus x degrees plus x degrees plus x degrees plus x degrees. This must give us 720 degrees. If we add 115 plus 89, we get our 204 degrees. Plus x plus x plus x plus x, we get our 4x degrees. B equals 720 degrees. Like terms, the 204 move to this side. So we have 4x degrees being equals to 720 degrees, and it becomes minus 204 degrees. Therefore, 4x degrees is equals to 720 minus 204. Here we get 6. 1, 7 minus 2 get 5. Then for x, we now divide both sides by 4. Our x is equals to 4 into 5, that's 1, remainder 1, into 11, that's 2, remainder 3, into 36, that's 9. So the value of x is 129 degrees. This is the value of x for 3 marks. This is 3 marks. Now, number 19, there's a diagram. There's a triangle there, triangle ABC. Then is a right angle at B. BCD is a straight line. AC is 12 centimeters and BCA is equals to 45 degrees. Then we are given some information there. Sine 45 degrees is root 2 over 2 and cos 45 degrees is root 2 over 2. Using as much of the information given above is necessary, calculate BC, leaving the answer in SAD form. So let's calculate BC. When we see right angle triangle, the first thing we should get in our mind is Pythagoras theorem or the trig ratios, the use of the acronym Churchill-Tau. Those are the two things which must enter into our mind. Either we use Pythagoras theorem or we use the trig ratios to solve these right angled triangles. So let's see how we're going to calculate side BC. On BC, we are given, this is the triangle. Let me draw it here. This is 12 centimeters. This is B. This is 45 degrees. This is C. This is D. And this is our A. So now for BC, this is BC. Now we look at the relationship between this angle and this side BC and also the side AC. So if we look correctly, BC is adjacent to this angle 45 degrees. So what it means is we have an adjacent here and also the hypotenuse. Then from our acronym Churchill-Tau, you can see clearly that the trig ratio with the adjacent and the hypotenuse is this. So it means for C we are going to use cos. So for BC we are now saying cos this angle, cos 45 degrees, is equals to adjacent over hypotenuse. So this now becomes cos 45 degrees is equals to adjacent, that's BC, over hypotenuse 12. And let's multiply both sides by 12 to make BC subject to formula. So 12 times cos 45, this is 12 cos 45 being equals to BC. What is 12 cos 45? Sorry, what is cos 45 there? Cos 45 we are given it as root 2 over 2. So this now becomes 12 times root 2 all over 2 is equals to BC. Then 2 into 12 is 6. 6 times root 2 we get 6 root 2 b equals to BC. So BC is 6 root 2 for 2 marks. This is how we get the value of BC. We cannot use Pythagoras because we are only given the hypotenuse only. The opposite, no value, and the adjacent, no value. So we use the acronym CHASHOTAO, where we have the adjacent, where we're now calculating the adjacent of this triangle, this right angle triangle. So it's adjacent of hypotenuse. So for today, I think let's end here. We are going to move on with the B in our next lesson. So please don't forget to subscribe to our channel. Tell someone to tell someone. Thank you very much. It's bye-bye for now.